And welcome back. So today we are talking about our third rigid motion, or our third transformation, and that is rotations. So rotations is a way that you turn a figure about a point. Things that you do need to know about rotations, unless they tell you otherwise. Rotations are always going to go counterclockwise. So a rotation, that is not as thick as I want it. Let's try that one more time. A rotation. And they always go counter clockwise, which means turn to the left. So we're going to come back from these rules, and if you want to memorize them again, you're more than welcome to, but we're going to define these rules first. So I'm going to start with A, which is in my pre-image of 1, 1. B is going to be at 4, 5. And C is going to be at 5, 3. So then if I take these and rotate them, again, counterclockwise. So I'm going to take this little image and rotate it 90 degrees to the left. To then get these ordered pairs, you're going to ignore the numbers that are here and what would this point be in relation to 0, 0? Well, -1, +1 is my new A prime. B prime is going to be at -5, +4. And then my C prime is going to be at -3, +5. So to get a rule, what happened? Well, from here to here, it looks like my ordered pairs, my X and Y on the ordered pair switched, and this value became negative. So we call that a -Y, +X. To rotate 180. So again, starting back with the original image, 90, 180. So again, in relation to 0, 0, what is this new A prime point? And again, I'm just going to use a single prime here just because I'm not really rotating these points to get to these. I'm rotating the original pre-image 180 degrees. So A is now going to be at -1, -1. B prime would be at -4, -5. And C prime would be at -5, -3. So what happens? Well, we kept X and Y in the same locations. They just both became negative. -X, -Y. For a rotation of 270. So I'm going to go maybe. No, I'm not. Just kidding. 90, 180, 270. Remember, they always go to the left. So A is now going to be at 1, 1. Sorry, 1, -1. B is now going to be at 5, -4. And C prime is going to be at 3, -5. So what happened between these two? Well, they switched places because the 3 is now first, and whatever this value was became negative. So we call that a Y, -X. A rotation of 360 just keeps that point the same thing, so it's X, Y. Again, you don't need to memorize these rules. I personally would plot and then turn my paper. And back to 360. So if I asked you to complete the transformation of rotation of 180 degrees on Fox, on Triangle Fox, So I would first note that F is going to be at negative 2, 1, 2, 3, 4, 5. Negative 2, 5. O is going to be at 1, negative 2. Actually, we don't even need to do that. I'm just going to take my paper and I'm going to rotate it 180 degrees to the left. And then I'm just going to jot down what are these new points. Well, F prime is now going to be at 1, 2, 1, 2, 3, 4, 5. So 2, negative 5. O prime is now going to be at negative 1, positive 2. And then X prime is going to be at 1, 2, 3, 4, 5, 2. So then if you want to go back to the original figure and draw this new triangle, you are more than welcome to. I'll draw this one, but I'm not going to draw that one. So F is now at 2, 1, 2, 3, 4, 5. O is going to be at negative 1, positive 2. And X is going to be at 1, 2, 3, 4, 5, 1, 2. And then there's my new triangle. Fox prime. For this next one, it says a rotation of 90, but because it has that little notation of CW, that means clockwise. Turn to the right. So I'm going to make a little notation here that's what that means. Turn to the right. So I already went in and plotted these points already. So I have A, which is at 3, 4. B, which is at 6, negative 2. And C, which is at 5, negative 5. So then I'm going to screenshot this so I can rotate it. If I rotate to the right, 90 degrees. Boom. So now A is going to be at 4, 1, 2, 3, negative 3. B prime, 2, 1, 2, 3, 4, 5, 6. Negative 2, negative 6. That's right. And then C prime, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 5, 5. And there's your ordered pairs for triangle ABC. Where do you see or perform a rotation on a regular basis? There are lots of places that happens. If you are turning a doorknob, if you spin around in front of the mirror, and again, rotations does not mean that it has to be that full circle either. What is the relationship between a pre-image and the image of a rotation of 360 degrees? They're the same thing. So if you start with this lovely little thing, maybe, and then I decide to spin it 360 degrees, it looks the exact same thing. For 3, write the rule to describe each transformation. So how did you move? So what I would do on these is I would map, okay, so how did I go from V to up here? Well, it looks like I'm turning it, so Yep, that's not what I want. Yep, that is not what I want to do. Hold on, pause that. Screenshot. So if I'm looking in relation to the black triangle to the blue triangle, so if I rotate, boom, 90 degrees. Well, that looks like the blue triangle that I have there. So when I asked you to write a rule for these, my rules are just going to be rotations of a certain degree. So this would be an R, 90 degrees. If you wanted to say a rotation of 270, you could. You would just need to notate that it's clockwise. If I look at this next one, okay, I want the black triangle to become the blue triangle. So remember, we always go from without the primes to the primes. So if I rotate this, is the black triangle in the position of the blue triangle? Yeah, well, how far did we turn it? 90, 180. Yep. So that's going to be a rotation of 180 degrees. And it is my bad that is the exact same question here, so we don't need to worry about that one. My bad. For 4, I asked you to rotate that triangle 180 degrees. So I'm going to go ahead and screenshot this line. And then I am able to turn my paper 180 degrees to the left. And technically, I guess it doesn't matter if it's 180. But to be in practice, 90, 180. And I'm just going to gather these new points. So A prime is now going to be at 4, 3. B prime is at negative 1, 2. Let's try that again. B prime, negative 1, 2. And C prime would be at 1, 5. For this next one, I gave you the ordered pairs. So I went ahead and graphed them. I labeled them. Rotation of 90 degrees. 90 degrees. It doesn't say clockwise, it just says 90. So ready, and boom. Rotate to the left one time, and we're going to read this like a new graph. So if I want U first, U is now going to be at negative 1, 3. U prime, negative 1, 3. V prime is now going to be at negative 5, positive 2. W prime is now going to be at 1, negative 2. And X prime is now going to be at 3, 1. And same for this last one. Rotate 270. I'm going to grab this figure right here. Screenshot it in. Rotate 270, so I'm going 3 times to the left. 1, 2, 3. And now I'm just going to read these ordered pairs. U is going to be, actually we'll start with T because that's in order. T is going to be at negative 5, negative 2. U prime is going to be negative 3, negative 1. V prime is, what is that, negative 2, negative 4? Yeah. And W prime would be at negative 2, negative 5. And then for this last one, design a symbol in which you utilize a rotation of a figure. That is totally up to you to get totally creative. If you were looking for like a real life example, I would use like the recycling symbol. And reason being is if recycle symbol. I did not spell that right, but it's okay. You didn't see that. Yeah, it's not gonna let me just drag and drop. Let me drag and drop. Hey. Shrink. So just FYI right here, I am performing a dilation to make it smaller. But I can start rotating it. And if you notice, those arrows at the top and at the bottom and on the side, they rotate along with it. So it's a rotation. So it's a symbol. If you wanted to know that, but that's on you. If you have any questions, please let me know. I'll be happy to get back in touch with you, and I hope you guys have a great day. See you guys soon.